Electricity, no matter how accurate we measure it, fluctuates between values. With this in mind, let's consider the linear graph that represents current versus voltage and how resistance can be obtained from it. Using different sources of voltages, we measure the current and plot the values in an x-y coordinate system. We will see that these values follow a trend of what ideally would be linear, the slope being the resistance. But like I mentioned, in practice, these values will fluctuate and will be scattered in a plane. This example gives us an idea of how the linear probability model works. To explain it, we will use the simple linear regression model. In this model, we explored the linear relationship of two non-deterministic variables. One is independent and fixed by the experimenter, in the previous example, the voltage. The other one is dependent and random. In our example, current will depend on the voltage and the value of the resistor. After the data has been acquired, the XY points will be shown as a scatter plot in the coordinate system. For the linear probabilistic model, we have several parameters that will give us the scatter points following a linear trend. First, we have b sub 0, which is the y-intercept of the linear equation. Then, b sub 1, which will be the slope of our increments in x. As you can see, these 2 points are the only thing we need to have aligned. That's why a random deviation or random error term is used. This variable will give us a point either below or above the true regression line, and that's how the scatter points are created. Let's see how this can be applied to material engineering. Let's say we want to figure out the yield strength of steel at different temperatures. Yield strength being the point at where plastic deformation begins, calculated with the stress versus strain graph. Note that for this example, the values are not experimentally tested but are close to what we would see in an experiment of this kind. The temperature will be our x value and the yield strength or y value. As we set different temperatures, our y value decreases since yield strength decreases as temperature increases. The scatter points will follow a negative trend, which will give us a line in between those points with a negative slope. As we can see, linear probabilistic modeling can be applied to many engineering practices. It is a simple way to study the relationship of two variables in an experiment and come up with conclusions about the linearity of the system or populations being studied based on the approximations given by this model.